Hello, fellow alchemists. Welcome back to our little mini-series about XML parsing. Since I did release the last video, actually I forgot quite a big thing to include, and I forgot it after I posted the video. I just remembered something extremely important. When you create your NIF, you have to be extremely careful that you actually don't block the scheduler. So some of the power of Elixir is that, of the beam actually, is that it could handle a lot of load, a lot of services and things like that running at the same time, and the services basically degrade over time, but they never actually stop. And so the way that works is that every process runs for a certain amount of what they call reductions, which is roughly a function call in Elixir. And after that, it has to, of course, surrender and stop, kind of pause where it is, and let another process go, and hopefully get scheduled again soon. With our NIF, at least the NIF code that we wrote, we actually don't ever run according to the scheduler. We just run until we're done, and that could be quite dangerous, and that could really bother the beam itself. And so there's two things you can do. One is that you need to, of course, run according to scheduler. There's ways to do that, and I don't want to go through that because it's a little bit complicated. In the future, maybe I'll try to write a NIF that does that. But the other thing you can do is that within a few years ago, there's a new thing called a dirty NIF, or a dirty scheduler, and they're basically either I/O bound or CPU bound. And so in this case, since we're not writing things or reading things from outside the beam, it's not going to be running on a dirty I/O scheduler. It's going to be running on a dirty CPU scheduler. And so all we need to do to fix this little problem is you just go to your code and you go to your NIF that you created over here, and you just change this to just be schedule dirty CPU, and that will fix our NIF for us. So now if we run this again, everything should work the same as before, and you see it does. Now the last thing I want to do is actually go over, how does this new code actually benchmark? So somebody mentioned before, okay, very simple test. It's very simple file. You should probably try something a little bit more complicated, etc. Yeah, we can make it more complicated, but I just want to first side by side with that one small piece of data. And so I'm going to add NIF to here. Parse.people, and then we have our NIF parse. Take our XML data in here, and we run that. Oh, sorry, this is running the test. If I run that, so that is parse XML bench, and we'll see how this goes. And there we are. Now, here's the interesting thing, right? If we take a look over here, so we can see our sweet XML is obviously the slowest, about 9, almost 10 times slower than our Saxy. And this is the interesting part that I always thought was really quite interesting, is that our Saxy parser is actually, 2 times higher than our, almost runs twice as fast as our NIF, which I thought was really amazing. So the way the Saxy parser works is actually much faster. But our NIF has much less memory usage. I tried to look into this. I think this may be a problem with the beam trying to measure memory and so forth. But yeah, this is what it comes up is this amount of memory. I think it's because we're passing a BIF to the NIF directly, and so there's probably some optimization, but I'm not too sure. But this is, I think, the most interesting part, is that the NIF, although really fast, it's only, it's actually twice as slow as the Saxy parser. Now, what I also wanted to show is that we can actually get this memory usage down a little bit. from Sweet XML and actually make Sexy run a little bit faster, I believe, at least a little bit faster. We can actually stream the results instead. So we have this file reading, we have this file streaming. So what we can do is for our NIF, since we can't really change it to a streaming API, we can actually, so what I want to do is I want to grab this and kind of see the whole flow, because we're not actually reading in the file in here. So path, and then we go over here, stick our path in here, and then for our Sweet XML parse, I'm actually going to make a separate function for this one, so that we don't, mess up what we already have. So we can go over here. Instead of taking a string of data, I think it's called a file stream. I'm not too sure. I can change that later. And so parse stream, we can just change this over here. And this one we can basically do the same. Parse stream, and we'll just steal this over here. Instead of parsing a string, you can actually parse a stream. So at least this should be a lot less taxing on the memory usage. For this one, we have to actually do some more optimization to make this a little bit faster. So there's a known issue with streaming the data, but it's okay. So what we can do is, instead of grabbing all this, we can actually do something called stream tags. Now what we do with stream tags is we take in the XML stream. Actually, we can just pass a stream directly, to be honest. I believe this actually just works by itself. So we'll go ahead and grab these. So XML stream file.stream. Take the path. And we can see how this works now. See if this should work. Sexy parse stream. Oh. Sorry. So this one. There we go. Try to run this again. See how it goes. So it should be a little bit less memory usage. So let's see, 125, 66 memory to 96. So it's even worse. But Sexy should be a little bit better. Sexy, maybe higher memory usage, it seems to be. Let's see, Sexy is 6.38 and 13.81. So higher memory usage, that's interesting. So what we can do to kind of make things a little bit faster, for this one, which actually helps with the memory usage over here, is that there's a Sweet XML stream tag. So then what you can do is there is a Sweet XML.stream tags. And so you can say, let's stream all the tags for people, and make sure that you discard them. So you have to use this. Let's see. And then you just pass in the stream into here. And then you can map that out. So then what comes after that is that you can just basically use a stream map on here, because the out's going to come, it's basically a stream. We don't need that. But what will come is there's going to be a function, of course. And so what the function will come in is something here along with the document. And then you can basically XPath the rest. So then we can use our our sweet XML.xmap on here with our document. And then this one should return people. And then of course we just do that. Something like that, I believe, should work. So we can just test this thing out. Try over here, see if this works. Let's see. Okay, so we got our, this is XML parse. People, sweet XML. Actually, so first we have to read the file in, so we have to get our stream. And this, of course, will be test, support, test, XML, join. So maybe this is path.join. Okay, so we got our stream over here. So now we can take our parse people sweet XML parse stream and pass in our stream. And no match of right hand side. Line 19. So this one should just be able to return. And we can just quickly recompile this one. Actually, we can just reload that. So XML parse.people. Okay, that returns a stream. So instead of stream.map, then we can just change this to an enum.map. So that way we don't get, we're going to get everything out automatically. And there we go. We basically have this, but now we have a double array, so we can just change this to be a enum.flatten. Let's take a look. Do we have an enum.flatten? So Elixir enum flat. We got a flat map. Flattens the result. Okay, but we have a list flat, right? Okay. So then we can just do list.flatten. There we go. So this should make it slightly less memory. We can take a look again, see how this works. Okay, so you see now, I believe we have a lot less memory used. Let's just take a look at the past. Well, I'm missing it. But I think we have a little bit less memory used this time, at least. So it should be a little bit better. But in any case, I think the most surprising thing over here, this is also interesting too, so take a look at this now. Now Sexy is slightly slower than an if. So if you stream it, it's slower. If you don't stream it, it's faster. That's really interesting. So yeah, I mean, if you take a look at this, there's lots of different things you can do, and you'd think that NIFs would be faster, but not necessarily. It could be the code I wrote in my NIF. It could be, just, I mean, the beam itself is already quite fast enough as it is, especially when you're working with data like this. So don't be too surprised. I mean, you can see sometimes NIFs can be slower, sometimes Elixir can be faster. It's, it's definitely different factors involved. It also could be the type of data that we're using. And also you'd be surprised about how some things could have a lot of memory. And having the stream tags actually helps with the memory for quite big documents, so you'd also be surprised. There's some issue on GitHub about this. And so this is how you can start to figure out, when you're working through libraries, you can figure out which ones could work better. You have to kind of benchmark them, see what works best for you and your data and your use cases, and kind of decide for yourself. So this is Alan from Plangora. Please subscribe if you haven't. Otherwise, I'll catch you guys next time. Thanks. Bye. Hi. Please feel free to ask us any questions about Elixir, Flutter, or anything else in programming. Here's our YouTube channel, Facebook, Instagram, and Twitter. We'll answer your questions every Friday. Ya Mantai Ge Duck Man All. Yo Wenti Ji Do Wen Wo